I am pleased to introduce first Michael James, the co-founder and chief architect of advanced technologies at Cerebras, thank you. Cerebras. If you haven't heard, they make the world's largest and most powerful computer processor, as well as the world's fastest AI inference and training program. We are going to get to the show and tell portion a little bit later. It's very exciting. We have a fun thing to show you. We also have Hira Dangle, who is the head of AI enablement at Analog Devices. He also spent 12 years at Bank of America as a VP of AI and ML. And Stefan Harris is the field chief data. Oh, Ilya Brown. Whoops. Ilya, thank you. Stefan's the one missing. Ilya is the chief product officer of Zifra and a seasoned product executive who's worked for Google, Twitter, eBay, Microsoft, and others. When Stefan joins us, you will know him as the field Chief Data and AI Officer of ThoughtSpot, and he's worked for NASA, Microsoft, and San Francisco State University. So we like to represent the Bay here. And scaling AI is the subject of the day. And first I want to start with Michael. Michael, largest, most powerful, fastest. NVIDIA went small, you went big. Why?
So we did make the world's largest computer processor. It is here with 30 centimeters from corner to corner. It is the biggest piece of silicon you can manufacture on modern equipment. And we only turn the circle into a square. There's about 1 million processing cores on this guy. Now, why we went large is because we see that AI needs a bunch of compute, but for the past 40 years or so, the field's been benefiting from Moore's law. We keep getting more transistors. They have less power to drive them, and so things go faster. And a lot of us have known that this trend is ending, and it felt like, the field of computer science might end. What are we all going to do? And in fact, it's our view that this has just been preventing there being innovation and creativity in the field. And as we're here on this sort of AI revolution, and we think, what is intelligence and what's powering it? If you asked people a while back, they would have said these are the formal rules of logic. This is what it means to think and be a person. And if you look today, what we've discovered is very different. We have these computers solving optimization problems and finding approximate solutions to underspecified equations. And that has to do a lot more with information movement. How can we get data to flow between memory and the chip? And we've got a substrate here that's big enough to integrate everything. And so that's why we have a large chip.
Your company has been at this for about a decade. When thinking about scaling AI, Michael, what remains your North Star in terms of what problems you want to address?
So I think that we are just at the beginning of this AI still. We have these models working with tokens, and when you look at what a person can do, you just see a world of much richer data with video and audio and multimodal, and we would like to see AI problems being solved in real time and at large scale on data sets that are hard for us to imagine today.
Mm-hmm. Hira, you created a 6-layered framework of machine learning ops deployment. Can you tell us about that, please?
Sure, thank you. I think if you look at from the application perspective, I normally tend to see like 3 per view today. Before ChatGPT came in, it was primarily just the MLOps standpoint, right? That's how we built. We used to build predictive AI, what do you call it, right? Now we're talking about primarily majority of the companies around LLM-based generative AI. And it's moving fast from that perspective to agentic, which is reasoning AI, into the physical AI era. So going back to this framework concept, when I was a visiting fellow at MIT Media Lab, my former company asked me, we're trying to introduce this AI journey starting from MLOps. How do we get started, right? That's where I think this 6-layer framework concept was introduced in terms of building this in-house influx of the data sources that's sitting across the multi-platform infrastructure, system of records, and master data hubs. So I came across this layered approach to introduce the expected business outcome as the output layer to serve the business workflows. So starting from this layer 1 approach to the layer 6, where the data sits in as the starting point, whether your data is unstructured or internal versus external, right? And then taking this approach into the layer 2 as a system of records, storing under different data plan, and then introducing data management functions, and doing all kinds of pre-processing that feeds into ML ops, which was the classic version of today's, LLM ops. As we compare a lot in terms of what's the distinction between ML ops and the LLM ops, how you can ingest those, well curated data into the training the models. Then I think doing the model evaluations until you get this expected performance evaluation matrices, so you can fully integrate the model output into your business outcome, right? Whether building your fraudulent detection systems to all kinds of the customer sentiment analysis that you can do to introduce from that environment to the business expected outcome. So it's a basically data ML model, and the output layer is where primarily I think the 6-layer framework has been very popular in my former work, and then I flipped that into ML ops to LLM ops as ChatGPT came on, but the structure has been not changed other than there has been common denominator, which is data. Data has a power to fuel both ML ops, LLM ops, and also today's world we're talking about the agentic AI, right? So.
Great. Ilya, I'd like to ask you about democratizing advanced AI systems, something your company Zephyra aims to do. What does that mean?
Sure, great question. So I guess at the heart of it, really what we're thinking about is how do we make it accessible to everyone, right? So how do we make sure that everyone globally has access to some of these advanced AI capabilities? And so to think through that, a lot of what we have to think about is how do we think about reducing cost? How do we make some of these models more efficient? How do we make them more accessible on other types of chipsets, other types of hardware? So you think about mobile devices, edge devices, different things like that. And then also, how do we think about different types of multimodal input capabilities, right? And so, a lot of what's proficient today is generally focused around this kind of chat-oriented type of experience. But how do we think about voice? How do we think about vision? And how do some of those pieces ultimately come into play in order to really make it more accessible to the masses?
I'd like to just tease this out for a second. Let's take audio. And you're talking about democratizing AI. There is a lot of excitement for audio, multimodal models, voice-activated synthetic audio. As I think about a democratized tool, I might think that that tool should be able to speak in any language. Or what are some of the things that you think about when you say democratizing? Like, in terms of voice, what does that mean for those maybe you don't have as much access to these tools as we have in this room?
Sure. So in terms of voice, I mean, I think we think about a few different pieces. For instance, right now we're working on a voice model for text to speech, and ultimately what we want to be able to get to is essentially voice to voice types of interactions. So to your point, you should be able to speak to a model that should be able to speak back to you. You could also imagine things like real-time translation. So you could be having a conversation with somebody else who speaks a different language, and the model actually is just playing the kind of real-time translator in between. So these are some of the types of scenarios that you would want to think about that would enable us to really kind of open up the use cases in terms of who can ultimately use these technologies.
What is the biggest challenge to scaling the concept of democratizing AI? Is it money?
So So I think the biggest challenge is really, I think, first and foremost acknowledging that you're not going to do it alone. So we take very much an open source, open science type of approach to this. We ultimately believe that it's going to come through partnerships. It's going to come through really incentivizing many different players to come together in order to deliver on this concept. So we work a lot with the open source community. We work a lot with different academic institutions, corporate institutions, in order to really kind of work through some of this.
Is it a challenge to remain open source? Does that need extra special protection?
That's a good question. I mean, I think that you have to be very intentional about what remains open source. I think there's very much a debate about this right now. I think in terms of what should be open source, what should actually be something that you kind of hold close. I think that a lot of the types of problems that we need to solve, I think, are complex enough that having as many eyes on it as possible right now is important. So if you think about things like privacy or data sovereignty, you think about things like personalization, what is going to convince the kind of non-early adopters to actually start utilizing these technologies? In some of the earlier conversations, I saw people talking about trust. So what's going to lead to trust of these types of systems? Is it going to require that everything happens locally on your own devices, or is it going to, continue to take advantage of these cloud or hybrid types of instances? And so I think that there's multiple layers of the stack that ultimately need to be addressed, to Hira's point, and that's going to require multiple players doing that.
I want to circle back, Michael, and ask you about scaling. You can't make this any bigger, can you?
Well, we certainly intend to keep growing on every dimension we can. And if I may also make a point on democratization, we see sort of the opposite of democracy if we just centralize all the power and control in one location. And as somebody who's you're providing custom silicon, custom circuitry to power AI applications, centralized control might mean that everybody just writes their software for a GPU, and that you have one ecosystem you build in. And so we're very much looking forward for the AI techniques to be powerful enough to fold in on themselves, that AI can help port the big software applications we have to other silicon platforms. And I think we'll also see a democratization, or at least a diversity of many different types of hardware that we can all use to do our work. And
what, in your opinion, now thinking about the democratization of AI vis-a-vis hardware, what is the biggest challenge to democratization of these products? Is it cost?
I think it's complexity. So there's just so much theory, and then layers of software and application and knowledge. And we all know this, that we don't work as individuals. We work in teams, and we'll soon have agents augmenting our teams. But it's the life investment you have to know to get familiar with something, and then bring it into practical use to actually start paying the value back out. And again, I think that AI is going to be making that easier for us all to experiment with different technologies, different applications.
Hira, what say you?
So the way I perceive this as from the ground up, the atomic level, which we're talking about, the silicon, right? It's a fundamentally more memory bound than the compute bound we're talking about. Think about all the systemic LLMs that's getting GPT. We're talking about like the GPU, TPU, and then all like precise domain-specific accelerators that's coming and it's getting deployed across cloud agnostic infrastructure to the edge computing that's coming, right? The LLMs or inferencing moving to the edge-centric kind of the devices. And that requires this kind of the intensive parameter interactions from compute layer to the memory, right? And that there's a data moment piece, which is one of the fundamentally bottleneck that we need to consider. Even a millisecond delay can impact the outcome that we're talking at the application layer, right? So that's the way I think the disruption needs to happen, to rethink about the architecture functions, how we can optimize the AI workflow at the top layer what do we call it as an application layer, and then bringing this inference as energy is becoming the new Moore's law, right? That's where I think the processing unit and the energy efficiency, power managements are the fundamental, I think, the building blocks that drives us when it comes to democratization of the AI solutions and the hardware components that help us to build the application layer that's coming out of the different kind of the nodes as a platform. Right? We see a SaaS application coming. There's a cloud agnostic view coming. There's edge computing coming. And the last one, I think we started seeing now physical AI, which is coming from like a humanoid robots to, right? That's kind of the different kind of distribution power we're seeing for the, as an application that's consuming across the different verticals.
And do you have any thoughts that you'd like to add to this?
Yeah, I mean, I think I would just add I think the application layer, I think that, it's really important for us to be thinking about what are some of the, very practical use cases for people to be using these applications for, right? I mean, I think that a lot of times we think about, some of the enterprise SaaS types of technologies and thinking about, how we're actually bringing all of these different data sets together. At the end of the day, today, data tends to live in many different silos. And so a lot of what AI can really help with is how do you bridge the gap and really kind of like pull these different data sets together in a way that ultimately is going to be useful for solving problems, right? At the end of the day, usually we're organized in teams because we're trying to solve a particular problem. And so the more that we can, the faster that we can, process that data and kind of get out of the kind of, process of actually looking for data and synthesizing that data, but really get to, okay, now how do we then leverage that for solving a problem? I think that becomes a really interesting case, and we see much more usage from kind of the non-early adopters there.
I want to just follow up on this bottleneck data question, and after that I'm going to open the floor for questions. So I want to ask, you mentioned a bottleneck of data. I think is what.
Yeah, I see data as a two parts, right? On the silicon level, which we talk about, compute versus the memory bound, that interaction that's need to have at the chip level. Then similar kind of conundrum is we're seeing on the infrastructure side as we started deploying models, traditional model versus the LLM-based models. There is a whole piece of, especially in the enterprise world, there's a data classification type of the work that you need to deal with as you move from experimentation prototype phase to production grade ready application, both on the generative AI, now mostly agentic AI is coming as a product view. Think about like public data versus private data, confidential data, and data classification beyond that, right? I think the primary bottleneck I see, it's just not the sanitized data, but also the readiness of this whole piece, what we call as a data governance, model governance. Now with the generative AI space, we're talking about the responsible AI, right? From ethical standards to compliance, privacy, and security piece, how you are putting those together and making sure that you have this system of review, what we call it as a conformity review process, that you can allow those builders, the application or AI builders to securely, reliably, and at scale, they can deploy product from 10 users to 10,000 to 100,000 or perhaps the millions of users. That's the skill we're talking about, right? So, and that's where I think the data is still the fundamental, the bottleneck to making sure that every business first, the data first decision has to happen to make sure that you have a stable or mature data infrastructure or the master data hub is available so you can scale out all kinds of different AI solutions. Call it MLOps, LLMOps, or agentic AI we're seeing, right? That's whole, I think, it's a fundamentally tied up to the first maturity of the data bottleneck we need to address at scale.
Can I add to that? I mean, I think even beyond just the data aspect, I think it's the context management aspect of it, because it's even if you could just say dump all of the data into some sort of a model, like not all data is created equal. And so I think that, part of what we have to be thinking about is how do you manage the context for a particular problem that you're ultimately trying to solve for, right? And so that whole layer of thinking about what is the context management layer, I think is going to be something really important as we figure out, already we're seeing that context windows are getting larger, and for different types of models, and I think that'll continue to happen. But even in those cases, it doesn't lead to allowing for the shortcut of actually really, I think, managing that context and really thinking about how that context is going to be used and how you might weight different pieces of that data in different ways for different problems.
Michael, do you have anything you'd like to add?
Sure. So we talk about data, and I get the feeling that the people are thinking that the quantity of data in our world is, can we get the data into the processor? And when you have efficient artificial intelligence, is usually based on some kind of sparsity. So we went from MLPs to convolutions, which they have a local receptive window. They're only processing a little bit. We now live in the world of transformers, and we have the attention. That means I'm only going to pay attention to those other parts of the context that actually matter, even though there was a lot. And the most popular way to run this context is a naive brute force search. You read every token of context for every token that the model outputs, and we're sort of disregarding all of computer science. There should be some kind of log time operation, not a linear time operation, just to do information retrieval. But to do that, you need different silicon structures. The reasons we're using poor algorithms are because the memories are in separate physical locations than the processors. And so there's a world that we'll be building towards where you fuse all of this. And we're actually working with DARPA on some advanced technologies to get way more bandwidth into these chips.
As we wrap up this session, I would just like to ask each of you for a final thought on silicon to systems scaling AI. How about you, Ilya?
Sure. So, I think at the end of the day, I think that there is no shortage of problems for us to solve, as we've seen here, everything from, how we think about hardware and chipsets to how we think about the different layers of the stack. I would just really encourage everyone to not just be heads down in their own particular areas, but also kind of periodically pop up and see what other folks are working on, because there's always exciting stuff. I've learned a ton since my, just short few hours here at this conference.
Yeah, I think taking from the foundational layer all the way from silicon, getting into this power efficient and energy efficient, it's going to be the collaborative efforts across silicon designers to the research scientists developing different algorithmic options, and then all the way the adopters on the enterprise IT system that is going to deploy those solutions, right? It's going to be the iterative process as we tend to see where the demand and how this disruption is continue to happen, right? It's how the cost and efficiency is going to kind of going up and down that directions, and looking at the, where the, this, the carbon footprint and the water footprint reduction stops happening, right? All on the data center deployment to the wide edge computing era. So I see the positive efforts is kind of the direction as we move into this inferencing per energy is going to be new law, Moore's law we're talking about, right? That's where I think we're all started seeing the disruptions against the incumbent. But I think in the next few years, we'll see more of those as an options, which becomes the a value add to the consumer end, right? That's what I think every technology has delivered to us in the past. So thank you.
So we're scaling AI because people see a lot of value, and we're reaping a lot of value from what was happening. And all of a sudden, computers are doing something qualitatively different than we are used to. So that there's a big investment and a lot of push there. And I think that there's also a lot of fear generally, and it's maybe societal fear. Will people still have a job? What is their role? But if you think of human enterprise, there are some really large, grand challenges that we're all working towards, and we should focus on these grand challenges. And can we use AI as a tool to help us achieve them? And you can think, does AI have a play at making fusion energy I come on a sooner time scale? Can we focus AI on some of the climate problems that we have? Can we develop from the basic AI we have now to something that's more of an AGI? Can we solve medicine and biological problems. There's a whole broad range of things that these technologies are going to be applied towards, and I think that we should be not so constrained on the tug of war side, but asking how can we help the technology develop to do some of the things we really need it to.
One last question.
So, I mean, you guys keep talking about Moore's Law, and it makes me think of Kurzweil and the Age of Spiritual Machines. And he was like, once we have enough, compute power on one chip, there's going to be the singularity. What's your take on that, and where are we on that timeline? I mean, I know on a light,
So I think you can look inside the brain and say there's a digital process there. The neurons we have are all or none. They fire or they don't, and you can use some of the AI models to put an fMRI or EKG, ECG, and actually decode some of the thoughts, and you can hook the LLM up and say, gosh, I guess I am a robot of sorts. And so if the AI can help us solve some of the fact that we're confined in our bodies, that we live for a short time, and have enhanced medicine and help teleport experiences or create some of the singularity, then why wouldn't we want to live in the sci-fi world? In terms of timeline, I don't think anybody could tell you.